In this video, we're going to be focusing on the idea of making lines. And so to start this video off, before we just jump into those concepts, I thought it would be a good idea to really go over the bell work that was with this lesson and talk about how to make lines just in general. So for the first question, we want to write the equation of a line with slope m equals 4 going through the point 5, 23. So the equation of a line is y equals mx plus b. So in this case, they tell us what m is. M is 4. So we have y equals 4x plus b. Now the issue here is we have the m part filled in, but you have to have the b part to actually make it a line and not just this kind of general equation. And that's where the point that they give us comes into play. So it's going through the point 5, 23. 5 is an x value, 23 is a y value. That means we can plug those in for y and for x and solve for b. So 23 is equal to 4 times 5 plus b, which means 23 is equal to 20 plus b. And if we subtract that 20 on over to the other side, we get 3 is what b is equal to. From there, this tells us that our final equation is y equals 4x plus 3. Now as we look at the second problem, they don't give us the slope, but they do give us 2 coordinates instead of 1. And this is where the slope formula comes into play. So our change in y's, 6 minus 2 over our change in x, negative 5 minus 3. 6 minus 2 is 4. Negative 5 minus 3 is negative 8. So this gives me a slope of negative 1/2. Now I have a slope. Now I can pretty much repeat everything I did in the first problem. Now the question is, well, I have 2 points. Which one do I use? Doesn't matter. They both come from the same line, so they're both going to give you that same line. So y equals negative 1/2 x plus b. And we're going to plug in the easier looking of the 2 points, 3 and 2. So 2 is equal to negative 1/2 3 plus b. And so from here, we get 2 is equal to negative 3/2 plus b. And for the sake of simplicity, we'll just make that a decimal. 2 is equal to negative 1.5 plus b. We'll add 1.5 to the other side, which means 3.5 is what b is equal to. So that gives me a final equation of y equals negative 1/2 x plus 3.5. So with that refresher, that's going to lead us into what this video is actually about, and that is creating parallel and perpendicular lines, given information about just one of the lines. So let's first off start by talking about parallel lines. Now parallel lines are coplanar. That means they exist on the same flat two-dimensional space, just like coordinate plane. They're coplanar lines that never intersect. No matter how far you take the lines, they will never intersect each other. These parallel lines have the same slope, so that means that their change, the way that they move forwards on the graph, is the exact same, but they have different y-intercepts. For instance, this one crosses at 2, where this one crosses at negative 1. So if this first line has a slope of 2/3, the second line is also going to have a slope of 2/3. They have to have the exact same slope. That's what makes them parallel to each other. Following that, we have another set of lines that are perpendicular lines. And perpendicular lines do intersect, but they intersect in such a way that they form a right angle at the point that they meet. And so because they're forming this right angle, what that means is that the second slope is a negative reciprocal of the first. Well, that's a fancy way of just saying that it has the opposite sign and is flipped. So if the first slope is still 2/3, then the second slope, we change it. So because it's positive 2/3, it becomes negative 2/3, and then we flip it. So it becomes negative 3/2. So they're the same numbers, but they're flipped. One's 2/3, one's 3/2, one's positive, one is negative. So if we look at some more examples, if M1 is 1/4, M2, we would flip it, so 4/1, which is just 4, and because it's positive, this would be negative. Put examples right here. If M1 is 3/5 negative, negative 3/5, M2, so because it's negative, it's now positive, because it's 3/5, it becomes 5/3. And if M1 was 2, M2 would be negative 1/2. So that is some examples of how we can see these perpendicular slopes interacting with each other. So we want to determine if the following are parallel, perpendicular, or neither. We have 4 options in front of us. Now if we look at 1 and we look at number 2, there are equations that are given to us, but these equations are not set up in such a way that we can easily see the slope. So we need to rework them a little bit. That means we need to get them to look like y equals mx plus b. That way we can focus on the slope. So in the first equation, we're going to subtract 2x to the other side, and that gives us y equals negative 2x plus 5, which is in the correct form. Then if we look at the second problem, we are also going to subtract 2x to the other side. So that gives us negative y is equal to negative 2x plus 4. But y is still not by itself. It has that negative with it. So we're going to divide this whole thing by negative 1, giving us y is equal to positive 2x minus 4. Now as we look, they have opposite signs. They have opposite signs, but they are not flipped versions of each other. They're both just 2. So number 1 is neither. Now as we look at number 2, same thing. So we want to add 2x to the other side. This gives us 4y is equal to 2x plus 16. And then we want to divide by 4, giving us y is equal to 1/2 x, because 2/4, 1/2, plus 4. For the second equation, subtract 2x to the other side. So y is equal to negative 2x plus 4, and then there's nothing left to do. Now as we go to compare these, this is a positive 1/2. This is a negative 2. These are perpendicular. They are negative flipped versions of each other. Alright, so as we section it off, make it a lot more clear to see, we go down to number 3. Now, just looking at the graph, it's really easy to kind of say, oh, it looks like it's intersecting at 90 degrees, but we have to make sure. We have to check the slope. So if we pick on this first slanted one, if we pick 2 of the points, we have a point here and a point here. Let's look at the rise over run. We go down 2 and we go over 1. So this slope is negative 2. Or negative 2/1 if you want to write it that way. Now if we look at the other one, we have a point here and we have another point here. So we're going over 2, we're going up 1, positive, so this is a slope of 1/2. Negative 2, positive 1/2, opposite signs, flipped versions of each other. This is perpendicular. So check the slope, don't just guess. Now number 4, if we look at it, it looks like it could be parallel. But again, we need to check and make sure. So we have a point here, and we have a point here. So that is over 2, up 1. But then if we keep looking, over 2, up 1, that's slightly off, over 2, up 1. So it's somewhere near 1/2, but it's not exactly 1/2. It looks like it's more than that. Actually, that point's not even on it, so if we look at it even further, that point's dead on it, so we have to go all the way over here and then up 1. So that's plus 9 and then up 4, so 4/9. So the bottom one has to be 4/9 for it to be the same. Well, this point is here, that one is dead on there, this one's also on, and so these are showing that they're all about over 2, up 1. So we're looking at positive 1/2 for this slope. Those are clearly not the same number. So the graph looks like it's similar, it looks like it's parallel, but when we actually look at the slope, it's not the same thing. So this one is neither. So now let's talk about actually making these lines. We're looking at them, we're able to decide and decipher if they are or are not perpendicular, but now we're going to actually make these parallel and perpendicular lines. So for our first one, we want to make a line that is parallel to y equals 4/5 x plus 2, and it passes through the point 1, 2. So if it's parallel, that means they have the same slope. So my new slope is also 4/5. Now to make a line, you need slope and you need a point. I now have the slope, I'm given the point. That means everything else about this equation, you don't even have to look at anymore. You only now focus on the slope that you have and the point you're going to plug in. So every single time you start making an equation, you always start out with just writing y equals mx plus b. And from there, we can plug in our x and our y value and the slope that we have. So we get 2 is equal to 4/5 times 1 plus b. Which 4/5 times 1 is 4/5, so 2 is equal to 4/5 plus b. Which, to save space, we're going to write it back up at the top. So 2 is equal to, and we're just going to call this 0.8 plus b. Now we're going to subtract that 0.8 onto the other side. And so 2 minus 0.8 gives us 1.2 is what b is equal to. So that tells us that our parallel equation is y equals 4/5 x plus 1.2. So now we're going to make a line that is perpendicular to y equals 2x minus 6, and it passes through the point 5/4. So if m1 is positive 2, that means my perpendicular slope, m2, is going to be the flipped version of 2, so 1/2, and then because it's positive, this is going to be negative. And again, now that I have the slope, I don't need anything else from that equation. Throw the rest of it away. Y is equal to mx plus b. Now we're going to plug in my slope of negative 1/2 and my x and my y value that I get from this coordinate. So 4 is equal to negative 1/2 times 5 plus b. Means 4 is equal to, and we'll just make it a decimal as we go to multiply this, so negative 5 over 2, which is negative 2.5 plus b. And then we're going to add 2.5 to the other side, which tells us that b is equal to 6.5. So my equation here is y equals negative 1/2 x plus 6.5. And that's how you make parallel and perpendicular lines. So as we do some more, Again, we're doing a parallel line, and then we're doing a perpendicular line. So for parallel, m, my slope, is going to be the exact same as the original. And now that I have the slope, we can throw away the rest of that equation. So y is equal to mx plus b, but I know my x and my y, I know my m, so instead I can do negative 9 is equal to negative 4 times 2. So negative 9 is equal to negative 8 plus b. Add 8 to the other side, and that tells me that b is equal to negative 1. So y is equal to negative 4x minus 1. That's my parallel equation. For the next one, we're doing perpendicular, so the original slope is 3/4. So my perpendicular slope, m2, flip 3/4, so 4/3, and because it's positive, it becomes negative. And so now I can plug in my new slope, negative 4/3, and my point, 12/3, to get 3 is equal to negative 4/3 times 12 plus b. So that means that 3 is equal to 12 divided by 3 is 4, and then 4 times 4 is negative 16 plus b. So then I add 16 on over to the other side, and I get b is equal to 19. So y is equal to negative 4/3 x plus 19. As we do another set, so because it's parallel, we're going to steal the slope from it, but as you notice, this is not set up in the way that we need it, y equals mx plus b. That means we need to take this equation and we need to rework it to make it set up to y equals mx plus b. So we need to subtract 2x to the other side. So 5y is equal to negative 2x minus 5. And then we need to divide out the 5 away from the y. So y is equal to negative 2/5 x minus 1. Now that we have the equation, we can steal the slope from it, so m is equal to negative 2/5. And from there we can plug it in to our equation. So y equals mx plus b, that means negative 8 is equal to negative 2/5 times 2 plus b. So negative 8 is equal to, and when we multiply this, we get negative 0.8 plus b, which we add to the other side, which means b is equal to negative 7.2. So y is equal to negative 2/5 x minus 7.2. And then for the bottom one, same thing. It's not set up as y equals mx plus b, so I need to make it set up as y equals mx plus b. So we're going to add x to the other side. We get 3y is equal to x plus 12. And then we're going to divide out the 3. So y is equal to 1/3 x plus 4. From here, my original slope is 1/3. That means my perpendicular slope, flip the 1/3, that gives me 3, and then because it's positive, I'm going to make it negative. So my perpendicular slope is negative 3. So y equals mx plus b, I have my slope, I have my x and my y, so 8 is equal to negative 3 times 9 plus b. So 8 is equal to negative 27 plus b. And I'm going to add 27 to the other side, giving me 35 is equal to b. So y is equal to negative 3x plus 35. And this equation is perpendicular to the original. So we want to find the equation of a line that is bisecting perpendicularly to the segment containing the endpoints 3, negative 12, 5, negative 4. All right, we need to break this down. Perpendicularly is everything we've been talking about. That means whatever the original slope is, we flip it, change the sign. Bisecting, what does that mean? That means if you have a segment, to bisect it, you're going to go straight through the middle. Which means that the point that this line is going through, if it's going through the middle, is the midpoint. So that means we have to do two things. We have to first find the slope of this original line. So m is equal to change in y, negative 4 minus negative 12, over change in x, 5 minus 3. So negative 4 minus negative 12 is positive 8. 5 minus 3 is 2. And 8 over 2 is 4. So that's my original slope. That means my perpendicular slope is going to be flipping this, so 1/4, and then changing its sign, so negative. The next thing I need to do is I need to find the midpoint, because that's the point that I'm going to be going through. So midpoint is equal to the x's added together over 2, the y's added together over 2, which gives me 8 over 2 and negative 16 over 2, which gives me 4, negative 8. So those two numbers, negative 1/4 and the coordinate 4, negative 8, those together is what I'm going to use to actually make this line. So from there, it's just everything we've been doing. Y equals mx plus b. So that means that negative 8 is equal to negative 1/4 times 4 plus b. So negative 8 is equal to negative 1 plus b. Add 1 to the other side, and negative 7 is what b is equal to. So my perpendicular equation is y equals negative 1/4 x minus 7. And this equation will bisect the original line, and it's going to do it through the midpoint. And for our last problem, the altitude of a triangle is a line that is perpendicular to a triangle's side and goes through a vertex. We want to find the altitude that goes through M. So M is up here. There's its point. And that means that M, the line that's going through M, this altitude, is going to be perpendicular to this bottom line K to L. So just like last time, we need to find the slope of K to L so that we can get the perpendicular slope for this altitude that we're trying to create. So M1, MKL, is 5 minus 0 over 10 minus 0, just 5 over 10, which is positive 1/2. That means that M2, if that's positive 1/2, M2 has to equal negative 2. So from there, we can now do everything we've been doing. So y equals mx plus b. So I'm going to use the 3 and the 12 over here. So 12 is equal to negative 2 times 3 plus b. 12 is equal to negative 6 plus b. And if I add 6 to the other side, that tells me that 18 is equal to b. So y is equal to negative 2x plus 18. So that's how you create parallel and perpendicular lines.